Hey guys, welcome back to Chemistry. I'm Mr. Silverstein. Today we're going to get into part 2 of isotopes. These slides are posted on your Google Classroom. Let me share my screen and let's get started. All right, so yesterday we talked about isotopes in part 1 and we spent our time looking at how the information shows up on the periodic table for the individual element. Today we're going to be able to use a picture or a description to determine the isotope of the element. Make sure you're taking notes in your spiral notebook. You will need a periodic table, and I have attached one to your Google Classroom for it. There's also a neat website that I'm going to show you called P-Table, which stands for periodic table, that you'll be using as well. Let's get started. Isotopes. So let's get a definition of isotope for you first. An isotope is one of two or more species of atoms of a chemical element with the same atomic number and position in the periodic table and nearly identical chemical behavior, but with different atomic masses and physical properties. So it is the same element, but a different species of it. And we're going to look at what that is. Every chemical element has one or more isotopes. And depending upon who is writing it out, it may look slightly different. Let's look at these examples here. We're going to use the elemental symbol C, and this stands for carbon. And on the bottom here is the number 6. Now, we know carbon is element number 6. It's 6 on the periodic table, and that 6 means it has 6 protons. So what I have here is I have carbon, and there's a 12 over here. And that 12 stands for its atomic mass. Now remember, atomic mass is the combination of protons and neutrons. So here we have carbon, and we're going to call it carbon 12. And over here on the right, we have carbon. We have our elemental number 6. But now I have a mass of 13. And so this one's going to be called carbon 13. They're both carbon, but they're a different species of it. Let's get into it. So, not all atoms of an element are identical. The isotopes are atoms of the same element with a different number of neutrons. The atomic number is the same for both, but the mass number is different. And we're going to look at that in just a second. So, let's take a look at hydrogen. Hydrogen is element number 1. It has 1 proton. And then we're going to look at an isotope of hydrogen known as hydrogen 2. Now, most elements are stable when the number of protons and the number of neutrons are the same. So let's take a look first at hydrogen 1 up here. And you might want to just draw this on your paper. Just make a little electron cloud and put the single proton in the center. Hydrogen 1 doesn't have any neutrons. So the mass number is just 1. It's 1 proton, 0 neutrons, or a mass number of 1. But if we look at hydrogen 2 below this, here we have an isotope of hydrogen, and it shows I have 1 neutron. So the mass number is now 2. I've got 1 proton and 1 neutron, and now its mass is 2. And we're going to look at some other isotopes in just a moment. But remember that an isotope is just a different species of the exact same element. So why are isotopes so important? Well, Isotopes of an element all have the same chemical behavior, but the unstable isotope undergoes spontaneous decay during which they emit radiation and achieve a stable state. Some isotopes will decay quickly and others take billions of years. This property of radioisotopes is useful in food preservation, archaeological dating of artifacts, and medical diagnosis and treatment. Now, because these isotopes are decaying, meaning that they are resolving back to a stable element, they have what's known as a half-life. That's how long it takes for the radioactive material to disintegrate. So the term half-life, and that's a vocabulary word for you to use, a vocabulary term, is defined as the time it takes for 1/2 of the atoms of a radioactive material to disintegrate. Half-lives for various radioisotopes can range from a few microseconds to billions of years. We're going to learn more about this decay in our unit on nuclear chemistry coming up next. Now, there is some isotope notation, and we can notate an isotope in one of two ways. The first way is the hyphen form. Make sure you're getting this down because you're going to find this on your quiz a little bit later today. It's the name of the element with a hyphen and then the mass number. So for example, potassium 40. That's going to tell us that it is potassium and its mass is 40. This would be an atom of potassium with a mass number of 40. And if you looked on a periodic table of elements and went to potassium, which by the way is K, you might find that its mass on the periodic table is not 40. It might be less or more. What's on the periodic table is the most common isotope. And we'll look at that in just a couple minutes. So hyphen form, potassium, hyphen 40. Now, this is going to mean that potassium has 19 protons because the atomic number of potassium is always 19, and it has 21 neutrons. So you can always calculate the number of neutrons by looking at the atomic number and subtracting that from the mass. Potassium 40 minus 19 equals 21 neutrons. The other way to note an isotope is what's known as the nuclear form. The nuclear form takes the mass number and puts it superscript before the symbol. And remember, superscript is a smaller type size to the upper part of the outside of a letter or symbol. So for example, potassium will show the elemental symbol with a superscript 40 on the upper left. Now, the nuclear notation can also include the atomic number below the mass, but it isn't essential since the identity of that element allows you to determine the atomic number. So, two different types of notation, and you're going to need to be able to recognize both of them when you do your homework and your quizzes. Hyphen form is the name of the element with a hyphen and then the mass number. It's up over here. Nuclear form is the mass number in superscript next to the elemental symbol. And it's really important when you're writing it that you be very careful that the size of that mass number, the physical size that you write it in, is smaller and to the upper left of the elemental symbol. Let's take a look at a couple of isotope notation examples. What I'd like you to do in your spiral notebook is to lay out these two different elements. The first one on the left is boron, And I want you to draw the nucleus and the first ring and the second ring. And in there, put the elemental symbol B, 5p for protons, 6n for neutrons. And then you're going to add the electrons, 2 in the first ring and 3 in the second ring. Remember, the element will always have the same number of electrons as it has protons. Then you're going to do the same thing for sodium. Sodium is Na. It has nucleus with 11 protons and 12 neutrons. Then it has 3 energy rings. The first ring has 2 electrons. The second ring has 8 electrons. And the third ring has 1 electron. Why don't you take a moment? You can pause this while you write that down. Okay, now let's look at the isotope notation. We're going to write the hyphen form and the nuclear form for each example. So let's look at example 1. Here we have the hyphen form is boron hyphen 11, because I have the name of the element, which is boron, and I add the protons and neutrons together, which is 5 plus 6, which gives us 11. The nuclear form would be a superscript 11 in front of the elemental symbol B. Now, I'm going to pause here for a second, and I'd like you to do example 2 on your own. And then we'll come back and we'll make sure you have it correct. All right, let's see what we have here. We have Na. We find that Na name is sodium. You have 11 protons, 12 neutrons. You add those together. Sodium hyphen 23. And the nuclear form is superscript 23 Na. So I'd like you to be able to make sure that you can always identify what your element is by first looking at either its elemental symbol or looking at its elemental name and finding the elemental symbol. All right, let's keep moving on. Next is we have to look at the average atomic mass. Now, if you recall from part 1 on this, you saw this hydrogen element in the little box which lays out on the periodic table. Here we have the elemental symbol H. We have the elemental name hydrogen. We have the number 1 representing the atomic number and also the number of protons and the number of electrons. And then we have down here this other number. It shows 1.01. And that is what the average atomic mass is of the most common isotope of hydrogen. And it is the weighted average of all the different versions of an element called the isotope. So let's say hydrogen had, for sake of discussion, 10 isotopes. You add up all the different masses, and then you divide it by 10 and you end up with the average atomic mass. You'll also sometimes see it called the AMU, average mass unit. Now, the average atomic mass is closest to the most common isotope of the element. Now, even though this is 1.01, we can call this hydrogen 1. We could also put it as a superscript 1 next to the H. So the average atomic mass is the weighted average of all the different versions of an element called the isotope. Remember, average atomic mass is another key vocabulary word for you. You should add that to your vocabulary section as well. Now, I want to show you a neat little periodic table known as p-table. And we're going to get more into that in our next discussion on the periodic table layout. But if you want to find the isotopes of an element, we can jump out and look at p-table. And you would find this on the web at ptable.com. And I'm going to stop this screen share. We're going to jump over to that. So let's just take a pause for a moment while I do that. And I'm going to share my screen and go to p-table. Where's p-table? P-table. Oops, not getting it yet. Here we go. So when we go to p-table, we see that this is laid out with all of the elements. Across the top, we can pick on properties or electrons or isotopes or the compounds that it can be made into. First, let's look at properties on the top left. Let's find the element we were just looking at, which is boron. So I move my little cursor over to boron, and if I click on it, it should open up to some other information. It's not opening up. Let's look at the isotopes of boron. If I click on boron, it should open up all the different isotopes of boron. And you can see that there's almost 19 different isotopes of boron. But the most common isotope of boron, look at the top left, is boron. It's element number 5, and its average atomic mass is 10.81. But if I look at another isotope of boron, how about we look at boron 7? Boron 7 still has 5 protons, but it has 7 neutrons. You can also look at the different information about boron. You can list the isotopes, boron 10, and so there's lots of information available on p-table. And I'm going to want you to spend a little time practicing with that. You can noodle around on there and see different pieces of information. And when we get into nuclear chemistry, you'll learn about alpha decay and beta decays and proton emissions and positron emissions and whether or not the element is stable or not. But there's lots of information for you on p-table. I'm going to stop this share right now. And now we're going to go back to our share, back to our slides. Okay, so you spend a little time using p-table on your own. Let's do a quick review of isotopes. You might want to jot this down as well. Atoms of the same element with different numbers of neutrons are called isotopes. Every chemical element has one or more isotopes. It can be presented in hyphen or nuclear form. For example, potassium -40 or superscript 40K, and remember K is also potassium. so it can be presented in hyphen or nuclear form. And unstable isotopes undergo spontaneous decay during which they emit radiation. All right, you're now gonna go back, double check your notes, open up the slides if you need to, and then go to the assignment tab and take the mini quiz. You're going to need a periodic table, and I've attached one to your Google Classroom. You can open that up. You're gonna have 2 minutes per question. Now, some of you might think, well, 2 minutes per question, that's pretty fast. The average person can respond to these questions in about 30 seconds, but you've got 2 minutes for it. There'll also be some flashcards available in there for you to do a little preview work and get yourself ready for your quiz. Well, that's all I have for you now. Make sure that you go through your notes, update what you need, then go off and take that quiz. Tomorrow, we're going to get into the layout of the periodic table. If you have any questions along the way, make sure you email me, and I'll be happy to get back to you fairly quickly. Without anything else for you today, you guys have a great day, and we'll see you next time.